Why the two most distant objects ever constructed by human civilization will continue their silent journey through the cosmos long after our planet has ceased to exist, and why the true purpose of the Voyager mission hasn't even truly begun. I need you to stay with me through this because this isn't a story about the past. You've seen the news flashes. You've read that Voyager 1 and Voyager 2 are running out of time. NASA is systematically switching off their systems, one instrument after another. Their power reserves are dwindling, and for most people that signals the end of the mission. But here's what's not being said. The mission isn't concluding, it's only just getting started, and what lies ahead stretches across a span of time so immense that the entire timeline of human existence becomes nothing more than a fleeting pulse. The Voyager probes are on the verge of becoming something they were never intended to be. No longer just tools of discovery, not merely collectors of data. They are about to transform into the most enduring testament that you and I and every soul who ever walked this earth ever existed at all. And tonight, I'm going to walk you through their journey forward, not over hundreds or thousands of years, not even millions, but billions. And what we uncover at the farthest end of that timeline is something so profound and so achingly beautiful that it will forever shift the way you see what it means to be human. Let's begin with where we stand today, because the present moment is far more delicate than you might realize. Both Voyager spacecraft rely on what's called a radioisotope thermoelectric generator. In simple terms, it's a sphere of plutonium-238 that naturally emits heat as it undergoes radioactive decay. That warmth is then converted into electrical power. It's an elegant system. It's dependable and it's fading. Each year, these generators lose roughly 4 watts of output. That might not seem like much until you consider that when they launched back in 1977, each probe started with around 470 watts. Today, they're operating on less than half that original amount. NASA's engineers have been working with surgical precision, shutting down heating elements, deactivating science packages one after another, hoarding every remaining electron just to stretch the life of their transmitters a bit further. But the equations are unforgiving. Sometime in the early 2030s, there simply won't be enough energy left to power even the communication system. The probes will fall silent. Their internal temperatures will plummet toward the void of absolute zero, and that silence will be complete. No signal, no ping, no whisper to confirm they're still out there. And that very instant, the moment Earth loses all contact, is not the ending. It's merely the opening chapter. Now, let me clear something up because almost everyone misunderstands this. The headlines shouted that the Voyagers have escaped the solar system. You saw it everywhere. Voyager 1 crossed the helipause in 2012. Voyager 2 followed in 2018. And technically, yes, they passed through the boundary where the sun's wind gives way to interstellar space. But when it comes to gravity, when it comes to the sun's true sphere of influence, they've barely stepped off the front porch. Stick with me here because the numbers are about to become almost unimaginable. To genuinely exit the solar system, the Voyagers must traverse something called the Oort cloud. This is an immense spherical shell of icy bodies and comets that encases our entire star system. And when I say immense, I need you to grasp the scale. The Voyagers, moving at roughly 38,000 mph, which is faster than any bullet fired from a rifle, will need about 300 years just to reach the inner boundary of the Oort cloud. 3 centuries. That alone is longer than the entire existence of the United States as a nation. But reaching the edge isn't the challenge. Fully crossing through the Oort cloud will take 30,000 years. Let me repeat that. 30,000 years to pass through a single structure surrounding a single star. Everything humanity has ever built, from the first marks on cave walls to the device in your hands right now, spans maybe 10 to 15,000 years. The Voyagers will spend twice that entire span just drifting silently through a field of frozen debris that most people have never even heard of. And throughout those millennia, they will be completely, utterly alone. The odds of them colliding with anything are essentially zero. Space is above all else emptiness. They won't smash into asteroids like in Hollywood films. They'll simply float, soundless, powerless, perfectly kept by the vacuum because there's no atmosphere to cause wear, no moisture to spark decay. They'll appear almost unchanged from the day they left Earth, aside from the slow abrasion caused by tiny grains of cosmic dust. Here's where things become genuinely mesmerizing. Because the universe is never still, stars are always in motion. And even though the Voyagers weren't aimed at any specific destination, the forces of gravity and movement have already mapped out where they'll be tens of thousands of years from now. Scientists have calculated their paths. They've run the numbers. And what they've discovered sends a chill through me every time I reflect on it. 40,000 years from today, Voyager 1, the speedier of the pair, will have an encounter, or rather, an encounter will have it. A star named Giza 445, A small red dwarf in the constellation Camelopardalis is gradually drifting toward our solar system, and in about 40,000 years, Voyager 1 will come within roughly 1.6 light-years of this star. Now, 1.6 light-years might sound trivial when I say it quickly, but let me put that in context. 1 light-year equals about 588 trillion miles, so 1.6 light-years is over 9 trillion miles. By any earthly measure, that's an unfathomable gap, but on the scale of the galaxy, it's a near brush. It's 2 ships passing on an ocean of infinite proportions. And here's what tugs at my heart about this moment. Voyager 1 will be lifeless. It won't capture images of that red dwarf. It won't gather readings. It won't transmit any message back home saying it has arrived. It will simply continue drifting past, indifferent, like a bottle floating by an island with no one inside to notice. If you're finding this as incredible as I do me a favor right now. Hit that subscribe button and turn on notifications, because the journey we're mapping is about to stretch far beyond anything you've ever pictured, and I don't want you to miss any part of it. Now let me share Voyager 2's story, because its path follows a different route entirely. After its encounter with Neptune in 1989, Voyager 2 was sent on a trajectory that took it below the plane of the solar system. 40,000 years from now, it will have its own stellar flyby, coming within about 1.7 light-years of a star named Ross 248. Ross 248 is another red dwarf located in the constellation Andromeda. But here's a detail that often slips by unnoticed, and it's remarkable. Ross 248 is moving quickly. In roughly 33,000 years, it will actually become the closest star to our Sun, temporarily taking the title now held by Proxima Centauri. So for a fleeting cosmic instant, Voyager 2 will be passing what is then our nearest stellar neighbor precisely as it drifts through our region. The timing feels almost poetic. After these encounters, 40,000 years out, both probes will sink back into profound darkness. And now time will lose any human reference. Centuries will become meaningless. We'll stop counting in years and start measuring in geological epochs. Here's what so many overlook about what follows. 296,000 years from now, Voyager 2 will experience another encounter, and this one is on an entirely different level. It will come within roughly 4 light-years of Sirius. Sirius is no quiet red dwarf. It is the most brilliant star in our entire night sky, a blazing blue-white beacon that is actually a binary system paired with a white dwarf companion. Picture that scene. A small metal craft built by human hands in the 1970s, weighing just over 700 kilograms, awash in the fierce glow of the brightest star in our celestial neighborhood 300,000 years in the future. By then, humanity on Earth might have evolved into something we wouldn't recognize, or we might have vanished entirely. Continents will have reshaped themselves. The climate will be beyond recognition, but Voyager 2 will still be there intact, bearing its payload, carrying out a mission that no one is watching anymore. Now I have to tackle the question I know is forming in your thoughts right now. Where do they ultimately go? Do they eventually drift out of the Milky Way? Do they float into the emptiness between galaxies? The answer is no, and the reason is elegantly straightforward. The Voyagers are fast by our standards. 38,000 MPa is astonishing for something we engineered, but it's nowhere near enough to break free from the gravitational hold of our galaxy. The escape velocity for the Milky Way is roughly 1.2 million miles per hour. The Voyagers aren't even close. They're permanently anchored, destined to become eternal members of this galaxy. They will fall into a vast orbit around the galactic center, much like Earth orbits the Sun, but on a scale that shatters comprehension. One full loop around the core of the Milky Way, what astronomers call a galactic year, takes between 225 and 250 million years. Let that sink in. A single lap requires 250 million years. The Voyagers will become artificial metal comets circling the supermassive black hole at the galaxy's heart, in an orbit so immense that entire species will arise and vanish between each revolution. They will glide through spiral arms. They will pass through clouds of interstellar material. They will silently observe the formation and extinction of stars that don't yet exist. And 4 to 5 billion years from now, when our own sun begins its final transformation, when it expands into a red giant and consumes Mercury, Venus, and almost certainly Earth, the Voyagers will still be out there orbiting, drifting, holding everything we ever were. Let me draw some connections here, because this is where it becomes deeply personal. Attached to the side of each Voyager probe is a 12-in copper disc plated in gold. You might have heard of it. It's called the Golden Record, and it is without question the most significant object humanity has ever produced. Not the most technologically sophisticated, not the most costly, but the most significant, because it was built to outlast the world that created it. The record's cover is etched with instructions written in what the creators hoped would be a universal scientific language. They used the hyperfine transition of hydrogen, the most common element in the cosmos, as a decoding key. The instructions detail how to play the record, and more importantly, where it originated. There's a diagram on the cover that pinpoints the positions of 14 pulsars, rapidly spinning neutron stars that function as cosmic beacons, triangulating the exact location of our sun at launch. Some scientists, including Stephen Hawking, cautioned that this was irresponsible, sending a map to our home address into the unknown. If hostile life forms exist, we've just handed them directions. But the reality of interstellar distances makes this danger nearly irrelevant. The true intent of the Golden Record was never to be an invitation. It was designed as a testament, a declaration of existence, a message that simply says, "We were here," and the contents of this record are enough to make you pause and rethink everything you take for granted. It carries the sound of rainfall, the rumble of thunder, the song of a humpback whale, the heartbeat of a mother, the sound of a kiss. It holds greetings spoken in 55 different languages, from ancient Sumerian to modern Portuguese. It features music by Bach, Beethoven, and Chuck Berry, traditional chants from indigenous cultures. It contains 115 images encoded in analog form showing our bodies, our structures, our nourishment, and our ways of caring for each other. Not our conflicts, not our weapons, not our darkest moments, but our finest. The people who crafted this record deliberately chose to present the universe with what we could be at our very best. If that doesn't stir something in you, I don't know what will. Hit the like button right now and tell me in the comments where you're watching from tonight, because I want to know how far this message is traveling. Now here's where it becomes genuinely humbling. In the emptiness of space, there's almost nothing to cause deterioration. No wind, no moisture, no oxygen. The primary threat to the Golden Record over cosmic timescales is micrometeoroid erosion. Tiny particles of dust moving at immense speeds that over billions of years act like cosmic sandpaper, slowly wearing away the surface. Studies suggest that the Golden Record will remain legible for at least 1 billion years, possibly as long as 5 billion. Let me repeat that because I need you to grasp the significance of this number. The Golden Record may survive for 5 billion years. Now think about Earth over that same stretch. 1 billion years from now, plate tectonics will have erased every remnant of our cities. The mountains we recognize will have been ground into dust. The sun, gradually intensifying, will have started to evaporate the oceans. Every encyclopedia we wrote, every hard drive we filled, every stone monument we carved, the pyramids, the cathedrals, the skyscrapers, all of it will be gone, dissolved, pulled back into the planet's core. But out there in the deep cold between the spiral arms of the Milky Way, Voyager will still be holding that golden disk. The grooves will still contain Mozart. They will still hold the brainwaves of Andrewen, the project's creative director, who sat in a lab and recorded her own thoughts as she reflected on love and the marvel of existence. She had just fallen in love with Carl Shawn, and she knew it while they were recording. Those electric thoughts, the neural signature of a woman in love, are frozen in gold, orbiting the galaxy's center in absolute stillness. This creates a paradox that is both sorrowful and breathtaking. It is entirely possible that the Golden Record will outlast planet Earth. The object we built to represent us will endure longer than the world we built it on. Our testimony will survive our existence. Now let me leave you with 3 thoughts tonight. First, the Voyager probes are not ending. They are evolving. The moment NASA loses contact is not a demise. It is a commencement. They will stop being scientific tools and become artifacts of the Milky Way. Silent monuments drifting through the galaxy on a scale that shrinks human history to a single heartbeat. Second, we are anchored. The Voyagers will never escape this galaxy. They will circle the galactic core for billions of years, crossing spiral arms, moving through stellar nurseries, outlasting our sun, outlasting our world, and in doing so, they demonstrate something unsettling and profound. The cosmos is unimaginably vast, and we are unimaginably small, and no amount of ambition can alter the laws of physics. Third, and this is the one I hope stays with you, the Golden Record is the most hopeful act humanity has ever undertaken, not because it will ever be discovered. The chances of that are almost non-existent, but because of what we chose to place on it. We didn't send our resentments. We didn't send our battles. We sent rain and melody and the pulse of a mother. We sent a species trying desperately to present its finest face to an audience that may never come. And that choice, that instinct to reach out with beauty instead of fear, reveals more about who we are than anything else we've ever built. When you hear the announcement that NASA has switched off the final instrument on Voyager, do not view it as an end. See it as the moment they finally embark on the journey they were always meant to take. The era of planetary discovery is over. The era of preserving human memory will stretch into infinity, 40,000 years from now. As Voyager 1 glides past that faint red dwarf, it will be only starting its voyage, and through it we will be traveling together, forever suspended in the vast cosmic night. Now, if you found this mind-expanding, you're not ready for what's in the next video. It's on your screen right now. Click it before you lose track. I'll see you there.